120 light-years away from us, there's an exoplanet that can potentially host life.
NASA is always coming up with crazy discoveries, but this one will make you go like, what?
Using NASA's Hubble Space Telescope, observe the smallest exoplanet to have water vapor detected in its atmosphere.
As it turns out, NASA has discovered a potentially habitable exoplanet.
Of a newly discovered world that NASA calls a super-Earth.
What's that? Well, an exoplanet, or extrasolar planet, is simply a planet that orbits a star other than our Sun. Now that we have touched base, let's get into the video. Number 1. 2I 715b and red dwarfs. 2I 715b, a super-Earth discovered orbiting the red dwarf star 2I 715 in the constellation Volans, has led to much interest among astronomers for its potential habitability.
Could affect the habitability of a planet.
Located approximately 136 light-years away, TOI 715b is classified as a super-Earth due to its mass, which is 3 times that of Earth, and its radius, which is about 1.5 times larger than Earth's. It completes its orbit around TOI 715 at a distance of 0.083 AU, circling the star every 19.3 days. One of the most compelling aspects of TOI 715b is its position within the star's conservative habitable zone. Discovered in 2023 by NASA's Transiting Exoplanet Survey satellite, TOI 715b stands out not only for its potential habitability, but also for the possibility that it may have a companion planet within the same system, further enhancing its significance in exoplanetary research. Red dwarfs like TOI 715 are smaller and cooler than our Sun, making them prime targets in the quest for habitable exoplanets. Moreover, red dwarfs are the most abundant type of star in the Milky Way galaxy, comprising about 75% of all stars. This abundance increases the chances of discovering potentially habitable planets in their systems, such as TOI 715b. Despite their promise, red dwarfs present challenges to planetary habitability, primarily due to higher levels of stellar activity that could affect the conditions on orbiting planets. Number 2. Kepler 186f. Kepler 186f holds a significant place in the world of exoplanetary discoveries as the first confirmed Earth-sized planet located within the habitable zone of its host star.
Stars with a low metallicity.
Situated approximately 580 light-years away, it orbits an M-dwarf star known as Kepler 186. This exoplanet has a radius 1.11 times that of Earth, making it one of the smallest planets known to exist within the habitable zone. While Kepler 186f's mass remains uncertain, estimates based on its size and composition suggest it could be around 1.44 times the mass of Earth if it shares a similar composition. It completes an orbit around its star every 129.9 days, at a distance of about 53.2 million kilometers, receiving about 32% of the sunlight that Earth receives from the Sun. The discovery of Kepler 186f has been pivotal in demonstrating that Earth-sized planets can indeed exist in the potentially life-supporting zones of other stars, greatly expanding our understanding of where habitable worlds might exist in the universe. However, further observations are necessary to ascertain if Kepler 186f possesses an atmosphere capable of sustaining liquid water on its surface, a key criterion for habitability. Current telescopes lack the capability to determine Kepler 186f's mass or atmospheric composition due to its distance and the faintness of its host star. Number 3. Kepler 10b is a super-Earth exoplanet located approximately 560 light-years away from Earth. It orbits within the habitable zone of its host star, Kepler-10.
then the gravity would feel uncomfortable.
With a radius 1.4 times that of Earth, Kepler-10b is larger than our home planet. Its mass remains unknown, but scientists speculate it could be similar to Earth if composed of similar materials. Discovered early in the Kepler mission, Kepler-10b represents one of the first exoplanets found by the Kepler Space Telescope. Number 4. Kepler-62e and Kepler-62f. Kepler-62e and Kepler-62f are two super-Earth exoplanets situated about 1,200 light-years away from Earth, orbiting within the habitable zone of their host star, Kepler-62. Both planets have a radius of approximately 1.6 times that of Earth. While their masses are not precisely known, they are expected to be Earth-like if they share similar compositions. These planets are considered promising candidates for potentially harboring life due to their location in the habitable zone, where conditions might be conducive to liquid water. Number 5. LTT 9779b, ultra-hot Neptune. LTT 9779b is an ultra-hot Neptune located about 264 light-years away from Earth, orbiting a G-type star. This planet is crazy because it challenges our current understanding of how planets form and evolve. What makes LTT 9779b unique is its size and environment. It's 29 times more massive than Earth and has a radius of 4.7 times larger. It orbits very close to its star, LTT 9779, at just 0.01679 astronomical units, completing one orbit every 19 hours. This close orbit means the planet experiences extreme heat, with its atmosphere reaching temperatures over 1,700 degrees Celsius. One of the most surprising things about LTT 9779b is how reflective it is. Despite its hot surroundings, it reflects about 80% of the starlight it receives, suggesting there are clouds in its atmosphere. This is puzzling because such intense heat would normally prevent clouds from forming, leading scientists to call this area around stars the Neptunian desert. Planets like Neptune are thought to lose their atmospheres in the Neptunian desert due to strong radiation from their stars. However, LTT 9779b challenges this idea by keeping a significant atmosphere, which makes up nearly 10% of its total mass. LTT 9779b's close proximity to its bright star makes it an excellent target for further study. Number 6. WASP 76b, hot Jupiter. WASP 76b orbits the star WASP 76, which is about 640 light-years away from Earth. This makes it a fascinating example of an ultra-hot Jupiter in the study of exoplanets. This massive planet is 85% as massive as Jupiter, but has a radius 1.85 times larger. It orbits very close to its host star, just 0.03 astronomical units AU away, leading to extreme conditions with daytime temperatures soaring over 2,400 degrees Celsius. What makes WASP 76b unique is its extraordinary atmospheric composition. Unlike planets with cooler atmospheres where metals like iron and magnesium condense into solid forms, on WASP 76b, these elements exist as gases due to the planet's scorching temperatures. A striking phenomenon observed on WASP 76b is the occurrence of iron rain. Strong winds transport vaporized iron from the planet's day side to its cooler night side, where it condenses and precipitates as molten iron. Recent observations using telescopes like Gemini North have detected ionized calcium in WASP 76b's atmosphere, suggesting incredibly strong upper atmosphere winds or even higher temperatures than previously estimated. The presence of rock-forming elements in WASP 76b's atmosphere aligns closely with its host star and the Sun, indicating that its composition likely originated from the protoplanetary disk during its formation. Number 7. HD 110067 Resonant Planetary System. The HD 110067 planetary system stands out as a crazy discovery in the field of exoplanetary research, characterized by its unique and stable configuration of 6 sub-Neptune planets orbiting a nearby bright star. Situated just 100 light-years away from Earth, this system has captured astronomers' attention for its extraordinary orbital resonances and long-term stability over billions of years. Comprising 6 planets smaller than Neptune but larger than Earth, each planet in the HD 110067 system orbits the host star in a precise chain of resonances.
Of discoveries formed along these lines.
Adjacent pairs of planets exhibit orbital period ratios of 3, 2 and 4. 3, a mathematical harmony rarely observed in planetary systems. Number 8. Bbop 1c, Circumbinary Planet. Bbop 1c, also known as the most beautiful exoplanet ever discovered, isn't ordinary either. It was identified within a binary star system, which is a relatively uncommon celestial arrangement. This circumbinary planet orbits around 2 stars, distinguishing it from planets that typically orbit a single star. It was detected through the Bbop survey, which specifically searches for planets in such binary star systems. In terms of its physical characteristics, Bbop 1ce is approximately 65 times more massive than Earth, placing it in the same weight class as gas giants like Jupiter.
10 times that of Jupiter.
This similarity in mass suggests that Bbop 1c likely possesses a composition dominated by gases such as hydrogen and helium, akin to the gas giants found in our own solar system. The binary star system that Bbop 1c inhabits consists of 2 stars that orbit each other. This dual star environment adds complexity to the planet's orbit and surroundings, providing scientists with a unique opportunity to study how such systems influence planetary formation and evolution. Number 9. GJ 9827d, Water-Rich Atmosphere. GJ 9827d is a crazy exoplanet recently discovered and known for its water-rich atmosphere. It's about twice the size of Earth, classified as a super-Earth. Despite its similar size to our planet, GJ 9827d experiences extreme temperatures, with surface temperatures reaching around 400 degrees Celsius, similar to Venus in our solar system.
Currently, the scientific team leading the study has 2 possibilities.
Using the Hubble Space Telescope, scientists have confirmed the presence of water vapor in GJ 9827d's atmosphere. Number 10. 2I 3757b. 2I 3757b is a gas giant exoplanet located around 1,000 light-years from Earth, orbiting a cool red dwarf star named 2I 3757. What makes 2I 3757b unique is its incredibly low density, similar to that of a marshmallow. This characteristic makes it the least dense planet ever detected around a red dwarf star. As a gas giant, TOI 3757b differs significantly from rocky planets like Earth, showcasing the diversity of planetary types found in the universe. Number 11. GJ15AB and GJ15AC. GJ15AB and GJ15AC are 2 super-Earth exoplanets orbiting the star GJ15A, located approximately 11 light-years away from Earth. Both planets orbit a red dwarf star and have a radius about 1.3 times that of Earth. While their masses are not precisely known, they are expected to have Earth-like compositions if composed of similar materials. Number 12. K218b. The K218 star system, located just 124 light-years from Earth, hosts 2 intriguing planets orbiting a red dwarf star.
And it's a world you'd want to visit.
Among them, K218c, which orbits very close to the star, is deemed inhospitable due to its extreme proximity. However, its sibling, K218b, has captivated scientists ever since the James Webb Space Telescope focused on it. Recent observations of K218b's atmosphere have revealed some peculiar findings. Notably, the presence of methane could indicate potential life, since it is considered a possible biosignature. Alongside methane, there is an abundance of carbon dioxide and a notable absence of carbon monoxide, characteristics reminiscent of Earth's atmosphere. The most intriguing discovery, however, is the potential detection of dimethyl sulfide, DMS, a gas known on Earth to be produced solely by certain algae. If confirmed, this could signify a direct detection of life on another planet, suggesting K218b might be a water world, also known as a Haitian planet. Number 13. Gliese 581g. In 2010, a team of astronomers led by Stephen Vogt from the University of California, Santa Cruz hit the jackpot with a cosmic discovery, Gliese 581g. Touted as the first potentially habitable exoplanet, this interstellar celebrity orbits the red dwarf star Gliese 581, chilling about 20 light-years away in the constellation Libra. Now, Gliese 581g isn't just any exoplanet. With a mass estimated to be 2-3 times that of Earth, it's a heavyweight contender in the rocky world category. It takes a leisurely 37-day orbit around its star, perfectly positioned in the so-called Goldilocks zone where liquid water could potentially exist, making it neither too hot nor too cold, but just right for life as we know it. Number 14. Gliese 667cc. In 2011, the European Southern Observatory struck gold with the discovery of Gliese 667cc, an announcement that rocked the cosmos in 2012. They used the radial velocity method, which is just a fancy way of saying they tracked the star's wobbles to find this gem. Gliese 667cc orbits the red dwarf star Gliese 667c, part of a cosmic trio located about 22 light-years away in the constellation Scorpius. Talk about a stellar company? This exoplanet is a hefty contender, having a mass around 4 to 5 times that of Earth. While its exact radius remains a mystery, it's speculated to be about 1.6 times larger than Earth if it has a similar composition. Number 15. KOI 5715.01. KOI 5715.01 is a cosmic superstar located a whopping 3,000 light-years from our solar system.
Ones you could visit anytime soon.
Nestled in the Goldilocks zone of its star, this planet ticks off the essential boxes for potentially supporting life. It's part of a planetary system that could be 5.5 billion years old, making it about 1 billion years older than our own solar neighborhood. Number 16. Kepler 69c. Kepler 69c is another heavyweight in the race for super-habitability. This super-Earth sits around 2,700 light-years away and is estimated to be a ripe 7 billion years old. This age puts it squarely in the ideal range for super-habitable planets. With a mass almost 4 times that of Earth, Kepler 69c could feature a single colossal continent with massive deserts at its center. But don't be disheartened. The coastline, washed by Kepler's ocean, could be the perfect spot for life to thrive. Number 17. Kepler 1126b. NASA's Kepler mission discovers bigger, older cousin to Earth. Then there's Kepler 1126b, another stellar candidate located about 2,073 light-years away. This planet is part of a system that's 7.5 billion years old, orbiting a yellow dwarf star much like our Sun.
1,000 of which have been confirmed as planets.
Kepler 1126b is 2.5 times closer to its star than Earth is to the Sun. But don't sweat it. This star is cooler, so the habitable zone is a bit closer. This proximity means it might just be in the perfect spot for life to flourish. Number 18. Speculos 2c. Closer to home, at a mere 106 light-years away, is Speculos 2c. Although it's still a hefty journey away, this super-Earth has some promising features. It's about 40% larger than Earth and could be a rocky planet like ours.
And by the Webb telescope. Now,
Speculos 2c orbits a tiny red dwarf star, only about 15% the size of our Sun. This close orbit means the planet is likely tidally locked, with one side basking in perpetual daylight and the other shrouded in endless night. Life could potentially thrive in the Terminator Zone, the narrow strip of land between the two extremes. Number 19. Water in space. For many space scientists, searching for signs of extraterrestrial life is a lifelong mission. Since life as we know it cannot exist without water, scientists naturally search for signs of water on other celestial bodies. Fortunately, we already have evidence that water exists in space. Space agencies like NASA and ISRO, among others, invest millions of dollars in the quest to find water on other planets. So, when water was discovered in a gaseous state near a quasar, it was a big deal. Scientists found a huge cloud containing more water than what exists on Earth, 140 trillion times more to be exact. This discovery, made by two teams of NASA astronomers in 2011, is one of the largest and most distant water reservoirs detected in the universe. Let's dive into the mysteries this space water holds. There is a giant water cloud, suspended in space in a gaseous state, located nearly 12 billion light-years from Earth, surrounding the black hole quasar, a massive cosmic body. This isn't the first time scientists have found water in space. There's plenty of water in the Milky Way galaxy, but there's a catch. Most of it is frozen. And that's all for today. Don't forget to like, share, and subscribe. See you in the next one.